Hello, this is Peter from Edico Mondo and a warm welcome to our STEAM project number 13 called The Countdown. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. The purpose of today's project is to learn about a new component, the 7-segment display. We will also learn how to approach a programming project in different ways. And the most important, we will encourage teamwork to be successful. This is the 1-digit 7-segment display. With these segments, the numbers 0 to 9 can be created. The segments are in fact LEDs. There is also an 8th segment, this dot, representing a decimal point. There are 10 pins coming out from the back of the display. I would like to introduce at this point that you can find all details of an electronic component on a datasheet. Here I am scrolling through the 7-segment display datasheet from HP. There is a general description of the component, the working of the inner circuit, the dimensions, and operating parameters such as temperature and humidity, all the way up to the color characteristics of the LEDs. Let's draw on the whiteboard how these pins are related to the LEDs on the display. The individual segments are named A, B, C, D, E, F, G, and either H or DP, which stands for decimal point. The sequence of these LEDs is quite standardized, but it is always safe to consult the datasheet when in doubt. Next, we need to understand how the 10 pins are related to the LEDs. The easiest is to start with the middle pins. These are your common cathode or anode pin. In our case, we have common cathode pins. Ask your students if they still remember whether cathode is negative or positive. Indeed, cathode is negative and should be connected to the ground. We connect both middle pins to the ground rail of the project board. Now your class needs to pay attention so that they will not make any mistakes when connecting the display to the microcontroller. Starting from the top row, the pin immediately to the right of the common cathode is segment A. Clockwise, we continue to segment B. Now we go to the bottom pins, and the first pin is the H or decimal point. Next is segment C, then segment D, and then segment E. Now we go to the pin to the left of the upper common cathode pin, and this is linked to the segment F. The last pin, at the top left corner, is linked to G. Your students will refer to this drawing a lot when programming the display, so best to keep this close at hand. You can also draw this on small cards and hand these out to them. Let's now distribute the components to your students. Here is the microcontroller and the breadboard, the 7-segment single-digit display. Because these are LEDs, we will also need 8 resistors of 220 ohm, a bunch of jumper cables, at least 10, a couple of preformed wires from different sizes, and let us not forget the most important part, the cardboard rocket. Building the project on the breadboard is in essence not that difficult, but because the components are very close to each other, your students will have to be very attentive not to put the wires in the wrong breadboard holes. First, we install the 7-digit display. Both common pins are connected to the negative rail of the breadboard through one of the small preformed wires. We connect the upper and lower negative rail with each other and make the connection to a ground pin on the Arduino. Next, we add the resistors to the remaining 8 pins of the display. Here I would like to pause for a moment and show you the difference in quality of components. Under the microscope, you can compare the wire thickness of the resistors. One is thin and flimsy, and the other is thicker and stronger. The thin wires will break easily and will be difficult to push in the holes of the breadboard. If you can, always go for the stronger components. To speed up the video, we already connected the resistors to the display pins. We can continue to connect the display to the Arduino. Segment A links to the digital pin number 2, segment B to pin 3, segment C to pin 4, D to pin 5, E to pin 6, F to pin 7, G to pin 8, and the decimal point to pin number 9. That's it for building the project on the breadboard. Now it's the time to start the programming. Before you continue, start a discussion in your class to think about different ways to program the display to count down from 9 to 0. In this session, we will show 3 ways to arrive at the same result. The first way is to connect each of the segments to a digital pin and define each number separately. The second way is to make use of a shift register, as we have already seen in lesson number 9, the laser bar. We will send a series of zeros and ones to the shift register, which will create a parallel output to the segments. And the third way is to include a library called sevseg.h. Let's have a detailed look at the first possibility. Ask your students to connect the microcontroller to their computers and let them open the Arduino integrated development environment. Because we will cover 3 scenarios and your students already have accumulated sufficient expertise in building a project, we will speed up. Add at the top the name of your new project. Project 13 Countdown. And this is also the place to declare the variables. We give the digital pins a name, and the easiest way is to simply link this to the segments. This is quite straightforward. INT A equals 2, INT B equals 3, INT C equals 4, all the way to INTH equals 9. We also add a delay of 500 milliseconds. INT GT equals 500. In the setup area, we set our pin modes to output. So all the pins from A to H have to be put as an output. In the loop section, we have to program through the digital write whether a segment will be high or low, or 1 or 0. Refer to the whiteboard or the reference card to identify the segments that will be on or off to create a number. You can show the first number to your class and then they have to do the rest on their own. Because the task is to count down from 9 to 0, we start with the number 9. On the card, we see that 9 is composed of segments A, B, C, D, F, and G. These will get a 1 or high. Segment E is not needed, so we put it at 0. Neither will we use the decimal point, so H also gets a 0. Now it's up to your class to create the remaining numbers 8 to 0. We have prepared this up front and will copy the code right now. Let them upload the sketch and show to you that the numbers are going down from 9 to 0. The second way is to make use of a shift register, as we have seen in lesson number 9, called the laser bar. We will send a series of zeros and ones to the shift register, which will create a parallel output to the segments. Repeat with your class the pinout of the shift register and check whether they still remember the data pin, latch pin, and clock pin. We start by defining the digital pins. So INT latch pin equals 3, INT clock pin equals 2, INT data pin equals 4, and we use a delay of 500 milliseconds. Looking at the reference card, we define the numbers 0 to 9 as the following set of binary numbers. And we create it by using byte, and then our variable num1, we set it to equals as 0b, which says it's going to be a binary number, and the sequence of zeros and ones. So for 1 it will be 0, 1, 1, followed by 5 zeros. And we do that for all of the numbers all the way to 9 or 0. In the setup area, we set the digital pins as an output. So we use our pin mode command, and the latch pin, clock pin, and data pin, all three are set as outputs. In the loop section, we first set the latch pin to low. Then we use the function shiftout with the 4 parameters data pin, clock pin, least significant bit first, and the first number 1. We will copy this and change the last parameter to num2, num3, num4, and so on. Give your class a couple of minutes to do this copy-paste and make sure that they do the change of the num the correct way. Let your students upload the program, and if all is well, this time they should see the counter going up from 0 to 9. For the last option, we use the same project as the first option, but in the programming we will make use of a library. The library that we will use is called cefsec.h, and through the function #include cefsec.h, we will call this library into our program. We also include a delay, and we create an integer, a variable that we will be using in a for loop. So we call it intj. And typical command for the library, we call cefsec.s. For the library, we will also need to define two arrays. The first array will be empty because we only use one digit. And the command is byte common pins with an empty array. So in between the curly brackets. We call the second array segpins, and here we add the pins 2 through 9, which we have used on the breadboard. So again, byte segpins is an array with the numbers 2, 3, 4, 5, 6, 7, 8, and 9. In the setup, we type the 5 parameters required for the function s.begin. To make our life easier, we will copy this first as a comment. We start with the function s.begin and the 5 parameters that this function requires. The first one is to indicate whether we have a common cathode or anode. In our case, it will be a cathode. Then we have to define how many digits we have. In our case, that will be 1. We also have to use the array common pins. We also have to use the array segpins. And we also have to indicate whether or not we have used resistors. A 1 indicates, yes, we have used resistors. So for our program, it will be s.begin, common cathode, 1, array common pins, array segpins, and ending with a 1. In the loop section, we can continue to write a very simple for function. For j equals 9, and for as long as j is larger than or equals to 0, j equals to j minus 1. And we use the function s.setNumber j, s.refreshDisplay, and we end with the delay. That's it. Let your students show that the counter will go down from 9 to 0. You can discuss with your students which method they preferred. Using libraries is probably the smartest and the shortest way, but we believe this should be reserved for more experienced programmers who already understand the ins and outs of the library. This concludes our project number 13, Countdown. What did we learn? Well, we learned about the workings of the 7-segment display. We have also explored that there are different approaches and methods to reach the same result. But the most important, we have encouraged teamwork in our class, and your students have been successful. In this lesson, we have been talking about displays. So here are a couple of suggested assignments. What letters can you program using the 7-segment display? Can you program the following words? Hello, bye. Change the code in such a way that the decimal point is lit before the number changes. Find the code of the SevSeg on GitHub and explain in the next lesson what GitHub is. These are just a couple of suggestions. Use your own experience and imagination to provide other assignments. I hope that you and your class enjoyed this project and that you and your class are eager to start with Project 14. In this lesson, we will complicate it a little bit more and we will work with a 4-digit 7-segment display, counting upwards with each push of a button. Bye bye for now, and looking forward to see all of you in our next lesson.